Statistical analysis is at the core of data science. Using statistics, you can learn about the distribution of the data, how much variance there is between values, and how values for one feature of the data seem to influence other values. The starting point for learning how to use statistics to analyze data is to understand the common descriptive statistics that we can use to understand the distribution of our data. Let's take a closer look at temperature. Here's a random sample of temperatures from Rosie's lemonade sales data. Now we want to understand the typical range of values for this temperature. So let's start with the lowest or minimum value, which you can see here. In Excel, we can find this minimum value by using the min function. So the lower end of our range of temperatures in this case is around 20 degrees. Now let's look for the highest or maximum temperature. Here it is. In Excel, we get this using the max function. And in this case, the maximum temperature in our sample is 64.2. Okay, so we've found the values at the extremes, and we might assume that a typical daily temperature lies somewhere in the middle of these values. But where? Well, one way to measure the middle value is to find the average or mean. Now, when we're dealing with a full population of data, for example, if we have a complete record of temperatures for every day, then the mathematical formula for calculating the mean looks like this, and we symbolize the mean using the Greek letter mu. Now this might look complicated, but all it's telling us to do is to add up all of the temperature values in our data and then divide by the number of temperature values that we have. Now we don't actually have all of the temperature values for every day here, we just have a sample of some of them. So we write the formula slightly differently, and we refer to the sample mean as an x with a bar over it, which logically enough we call x bar. The calculation, however, is just the same. In Excel, you would simply use the average function, which in this case gives us a value of around 44.62. Now our mean looks to be more or less in the middle, but that might not always be the case. We might have had one or two extremely cold days that drag the average down, even though most days were warmer. So another way to measure the middle value is to sort the data into ascending order and find the value that has the same number of values above it as below. Now in this case, there's an odd number of temperature observations, and the 8th value has 7 values above it and 7 values below it. If we had an even number of observations, we'd just take the average of the middle two values. Either way, this value is known as the median, and you can calculate it in Excel using the median function. It can often give us a better idea of the central value in our data than the mean if the data is skewed by some extremely high or low value. Now, part of the reason we want to find the middle value in the first place is so that we can give an indication of what we might expect a typical temperature value to be for any given day. It might be reasonable to expect that this typical value will be observed more frequently than other temperatures. Now, as it happens, in our temperature values, the value 46.2 appears twice, while all the other values appear only once. So this is the most common value. And we call this the mode. We calculate it in Excel using the mode function. In this case, the mode happens to be the same as the median, but that's not always the case. Also, in many cases, data can be multimodal. In other words, there might be more than one value that appears more frequently than others. Now, if we were to count up the number of times each observed value occurs in our sample, in other words, the frequencies of the values, we could visualize them like this. This type of chart is called a histogram, and it shows the frequency of data values within distinct ranges, or bins. And in this case, each bin covers a range of 10 values. Note that the mode, being the most frequent value, causes a peak in the data set. And in this case, the mean, median, and mode are all more or less centrally located, with symmetric tails on the left and right showing progressively fewer values for more extreme temperatures. When data is distributed as a bell curve like this, we call it a normal distribution. And statisticians love to work with normally distributed data like this for a number of reasons, some of which we'll explore later. Another way you can visualize the distribution of your data is to use a box and whiskers plot. In this case, the box in the center represents the inner two quartiles of the data, with the median showing as a line. In Excel, you can also display the mean as an X. The whiskers show the rest of the data to the minimum and maximum. You can show a box and whiskers chart in this horizontal orientation, but often, especially in Excel, it's shown in this vertical view.